Okay.
Not that good.
Okay, we are actually not doing any calculus today.
Oh my gosh.
Oh boy.
Where are we here?
No.
What's the
Before we can do the calculus of polar curves,
If you say physics, I'm leaving
No.
the room.
I also hate physics.
desk
So.
and
No, we're just doing some pre-calculus review of polar curves. What does it mean to graph a polar function? What is a polar coordinate? No, I'd have such a strong reaction from that.
Gonna have to go and watch the recording.
So we are just going to talk about graphing polar functions, how to switch back and forth between rectangular and polar coordinates and functions.
She's trying to put us at ease. She said just.
And then
Don't fall
tomorrow
for it.
we'll talk about some of the calculus of polar curves. So we all know how to graph a rectangular coordinate. Now I only wanted to go to 2, but it's not very big on here, so I'm going to mark mine differently than this and say that 2, 2 is here. So to find a rectangular coordinate, we all know that we count from the center. We do.
Yeah.
The first coordinate tells us to count right 2. Second coordinate says count up.
Oh, center like that. I thought you meant like diagonal. I'm like, what is this magic?
No, from the origin, center. And we all know that this is represented as an x, comma, y.
Oh yeah, I remember that. I think we learned that in calculus.
Okay. Polar coordinates are represented differently. If I want to plot the same coordinate in polar form, this point would be the point 2 square root 2, comma, sorry, that should not have had a comma. I was thinking ahead to, yeah, I would have to put in a comma. 2 square root 2, comma, pi over 4. Those 2 points are the same. Just one is rectangular, one is polar. So let's talk about why. When we are in polar coordinates, instead of counting from the origin right and up, we're going to have r for a radius and theta for an angle. So radius and our angle. So angle-wise, we should have familiarity with that from trig. If I said pi over 4, you would know we would take some line and actually rotate it. I don't know if I can actually rotate it on this. No.
Oh, so I can make my circle.
We would take some line and we would rotate it pi over 4 radians. Well, how do I know where to stop that line? That line could go forever. Well, the radius tells me where to stop it. I would actually need the distance on this line of 2 square root 2, whatever units I have to be in. So the radius just tells us when do we stop that line. The angle tells us where do we rotate that line to. Now, with polar coordinates, I could actually label this a couple of different ways. 2 square root 2 pi over 4, that would be the same as 2 square root 2, no, I think I have that wrong. 2 square root 2, what's 2 pi minus pi over 4? 7 pi over 4? Okay. Negative 7 pi over 4. You don't? Okay, that is the same as this. This would give me the same point. Because negative 7 pi over 4 says, start at our think it's called the terminal side, or no, start at the initial side, rotate 7 pi over 4 in this direction, and we'd hit that same line. So the 2 square root 2 still gives us that same radius, but the angle, I can name that angle an infinite amount of ways.
Big game show.
I could say, let's see, 2 pi plus pi over 4, 9 pi over 4. I could say 9 pi over 4 instead of pi over 4.
Do you just say it's hard?
Probably. I could say 17 pi over 4. I have an infinite number of ways. So a second thing that can also make polar coordinates confusing is that this first value implies a direction. Okay.
She finally experienced empathy for the first time this year from me.
If I said negative 2 square root 2, why do I keep putting the comma?
I didn't say I
In the
was
wrong
experiencing empathy for you. I said you're experiencing it for me because that's what I felt every day.
Oh.
Okay, so if I said negative 2 square root 2 pi over 4, well, rotating, I'm still rotating to here, but we really consider this entire line. The negative says instead of starting and pointing up, we're going to start and go the other direction. So if I put a negative in front of that 2 square root 2, it is actually giving me this point here. So it can be confusing. Polar coordinates are more confusing than rectangular.
Nah.
But the advantage of polar coordinates is there are certain functions that are really complicated in rectangular and are super simple in polar. So we want to be able to go from rectangular to polar coordinates or polar coordinates to rectangular coordinates. So with these pictures, we can actually find the formulas. So rectangular-wise, this direction would be x, this direction would be y, but we know in polar coordinates, we really want the radius. So how could I use x and y to find the radius, looking at that picture?
A squared plus b squared equals c squared.
That's Pythagorean theorem.
A squared plus b squared equals c squared. It's a right triangle, Pythagorean theorem.
I think I'll have a formula named after you someday. It's the Ben.
Okay.
2 plus 2 equals 7.
That'd be a pretty good formula.
So in our polar to rectangular, this would be a formula we're going to use.
That doesn't make sense. Sorry.
Okay, we can also find the angle. If I want to know this angle, well, I'm limited because I have to use the x and the y to find the angle. What trig function would use that x value and that y value? Opposite over adjacent, which is tangent.
Yeah,
So tangent theta,
wait, did you put project to rectangular twice? Or
no,
did you-
rectangular to polar, we still have to fill in the formulas for.
Oh. Rec. And take to rectangle.
And I'm just going to redraw the picture. So we know polar
Shows and be nice. Ladies and
has an r and a theta. And we know we want x we know we want y. So we are going to have to find these separately because I want to use r and theta to find x. So if I'm restricted to just using r, theta, and x, what trig function would use r, theta, and x? R, theta, and x adjacent over hypotenuse is cosine. So cosine theta would be adjacent over hypotenuse. But we want to know what x equals, so what would x equal from that?
R cosine theta.
R over, no, R times cosine.
R times cosine theta.
Good.
So if we were going to do that for y, it's going to be very similar. Instead of using cosine, though, we would use sine. So those four formulas are how we transfer back and forth between polar and rectangular, or rectangular and polar.
That's it.
For now. Then we're going to do an example.
No, no,
No.
I'm just wondering, is that like the
Yeah.
only formulas?
Those four formulas are what we need for moving back and forth between polar and rectangular.
So we're going to add more to that?
We're going to add some calculus formulas tomorrow.
Oh, so we should leave
Today,
space.
those are all the formulas we need.
Or are we just going to use different?
We did, don't worry.
Just, alright, you sure or don't?
Okay, does everyone have those four formulas down before I move to? Okay. So plot the polar coordinate and then find the corresponding rectangular coordinate.
I think I failed this unit last year.
That's nice.
I totally flunked it.
Well, hopefully having seen it once,
Don't think I can
it will
turn
be better the second time around. Now, what's kind of funny about polar coordinates, not haha funny, but weird funny, is that
I was
even
ready.
though this is r and theta, our coordinate plane is still x and y. I don't need to change that to an r and a theta in order to graph.
Isn't there like actually a polar coordinate graph thing?
Yeah, it's just,
It's like circles.
yeah, it's just so that you can, I mean, it's still really the xy plane. They just did a circle at 1, did a circle at 2, did a circle at 3.
It's just so much easier.
Hey, didn't we get, how do we learn this? We used those last year.
Yeah, that's why I said if she's teaching us physics, that would be made
But in the calculus book and on the AP test, they would not use a graph like that. They would just do off of the xy plane. So we know we have to travel pi over 2. So starting on the x-axis, we have to travel pi over 2. Where will that take us to? Okay, the y-axis. We travel to here. And we know we have a radius of 4, so we know we're on the y-axis at 4. We don't have to draw the entire line to plot the point. Drawing the entire line is just to help us plot the point, but the point itself is independent of the line drawn from the origin. So there is my coordinate, which we can name the rectangular coordinate for that really easily without even doing any math. 0, 4. If we look at the graph, that's located at 0, 4. What if it's not so simple? What if we have something like out here that we're not 100% sure of? Well, that's where we use
Calculator. X equal for
x equals r cosine theta and y equals sine theta.
That's telling me how it passes.
Yeah.
Hmm.
Oops. I mean, you're supposed
I
to
think
do
I
that.
did label them wrong. I think I put the rectangular to polar and polar to rectangular in the wrong spot.
Yeah,
Are you serious?
I wrote it down
There
on
we
the crap and
go.
erased it and put it
I
back.
saw Emma's confusion before. I'm like, did I put those? We'll check later.
I put those back down backwards and then I highlighted them. So
So I have to like.
As long as you know the four formulas, doesn't really matter so much. So what would I replace r with?
Gosh, you just saved me.
Got you,
It's
back.
gonna be like,
4.
I put those names behind you. Bring them up.
4 what would I put in for for
Pi
theta?
halves.
Pi halves.
Pi halves. Which gives us
4 cosine pi halves.
0. Cosine of pi halves is 0.
It is? Yeah, because it's 0.
So cosine is the x value for sine pi halves. 4 times 1, which is 4. So our rectangular coordinate is 0, 4. And there's our math to prove it. So I want you guys to try one. I did make this one harder to graph because they're both negative. They're going to go in the opposite direction when we graph it.
You made it hard to graph?
Mm-hmm.
Why would you do that?
Okay. So what did you guys get for your point? Negative 1, 1. So when we go and plot our point,
Yeah, I got -1.
and that's the point you should have gotten originally. That's the point you should have gotten originally when you plotted your polar coordinate. It's not that easy to get these guys off track, or not that hard. Wrong word. Not that hard.
I was gonna say, that's a compliment in my book.
About to say, what calculus class have you been?
Yeah.
Okay.
Wait, -1, 1, is that right?
So then, if we're gonna go from rectangular to polar.
You could just say broken angular.
And graphing this should be pretty easy because it's rectangular. It's something you've been doing since like 6th grade, hopefully. So 1, 0. So graphing that coordinate shouldn't be too hard. But then we need to find the polar coordinate that goes with that. So we had our r squared equals x squared plus y squared formula. So how are we going to find our radius? Solve for radius, because we have an x and a y. So 1 squared plus 0 squared.
559. Wow.
So r would really be square root of 1, which is 1. How would we find the angle? What's our last formula that would give us angles? Tangent theta equals y over x, right?
Sorry, off topic, but I'm afraid that when I'm in college, I'm going to like the Greek row and not know what anything stands for. That's one of my biggest fears, you guys.
The sorority and
Oh,
No,
no,
Greek row is.
no,
Oh my
I-
gosh. Such a child.
sophomore.
I'm not a sophomore. I am a child, but not a sophomore.
You're making fun of Melinda that time.
My name is not Melinda.
So are you.
So sad.
You are the most humble person I've ever met. And everything's
Okay.
about you, child.
Inverse
See,
tangent
you
of
said I was a
theta.
child. I'm telling
I
you.
said that wrong. Inverse tangent of 0.
Why would you do that?
When does tangent equal 0?
Sororities and frat houses?
Does it ever equal?
They all have, they're like,
I've never heard it called that.
all of them are Greek letters. They're like pi, gamma, delta, or
Yeah.
Oh, what's
lambda, rho.
Well, I've never heard them called Greek row. That's weird.
call it that?
Where is this?
I've never
Haven't you
heard it
seen the
called
ABC Family Show Greek?
No.
No.
You're not messing much.
I don't.
Wasn't
watch
worth watching.
stuff.
Well, that's what it's called. Now you know. A sad soul.
I'm sorry. I really don't care what they call places.
Only your reason.
Okay. So,
I just don't watch TV.
inverse tangent of 0 now. What is the angle? 0 is 1.
Speaking of waste of time.
What else would be inverse tangent of 0?
2 pi.
Oh, I thought
2 pi would be 1. What else?
Or
4 pi? 6 pi, 8 pi, negative 2 pi.
Times 8.
Wouldn't pi also be a spot where inverse tangent is 0? Or am I?
We're gonna laugh.
Because tangent would be 0 where tangent is sine over cosine, right?
I thought it just went 0 before.
Sine over cosine is 0. So really we just need to know where is sine 0. Well, cosine sine. Sine is 0 here, and sine is 0 here. I'm just saying. Those are all some possibilities. Okay, but if we used like pi, to get the point back that way, we'd have to make r negative 1. So if we just use r positive 1, we can do 0. Or r positive 1, we can do 2 pi. Because I wanted you guys to name more than one. We're going to skip that try problem because we're running short on time.
And we're not even running.
So there are some common polar graphs that you should be familiar with. Sorry, one side is upside down.
Hey, you were doing some. Wait.
Yep.
Back over. You were doing some of those.
He was doing a rose curve.
Oh, it is upside down. That's why I can't read it.
Those are fun.
I was doing a rose curve.
Oh, I remember these last year.
Okay.
Yeah, no, mine had 9 points. That only has 8.
So yours
It's so much cooler.
I
would
remember when we did
NV
one that was like,
a lot. So these are some common polar curves that you should familiarize yourself with so that they're not so unexpected on the AP test. We have the rose curves, circles, on the other side, Lima, I have no idea how to say that, honestly. Limason curves or Limacon curves, lima bean curves, I don't even know. It kind of looks like a lima bean, I'm just
Hey,
saying.
go ask Miss Agrins. She knows it.
I call the one
Oh, Limacon.
Yeah.
Limacon.
Well, the C has the little,
Yeah.
Well, I see where you
Something
came up with
underneath
the
it.
lima beans.
Every time it just dies.
so equation-wise, you should familiarize yourself with those graphs, get an idea of what is used. And then we also need to be able to convert not only from coordinate form, but from equation form. We want to take this equation, y equals x squared, and we want to write it in polar form. So again, we're still just going to use the formulas we have. Going from rectangular to polar is pretty darn simple, because all our rectangulars are using y's and x's. And what do we know about what y equals, and what do we know about what x equals? What do we know y equals in polar form?
Y equals.
Our sine theta. What do we know x equals? Our cosine theta. So to switch this to polar form, all I have to do is substitute. So switching from rectangular to polar, pretty easy, because all we're doing is substituting. We know y is our sine theta, x is our cosine theta. Now, if possible, we usually get r alone. This one, we wouldn't be able to get r alone. So we would just have a more complicated version. This one would be not one of the ones on your list. The ones on the list are all just r equals something. But converting from polar to rectangular is a little bit harder, because not often do they have exactly what we already have for the formulas in the equation. Sometimes they do, a lot of the times they don't. So we have r equals 4 sine theta. Well, we know the two formulas we're going to focus on are x squared plus y squared equals r squared. Actually, we also need to think about the y equals r cosine theta. Or wait, sorry, y equals r sine theta. And x equals r cosine theta. And those are pretty easy to remember because x is always the cosine coordinate on the trig circle. You should already associate x and cosine, y and sine. And not as useful, but can sometimes be used, is this. Well, right now, none of these fit those formulas exactly. We have an r all by itself, but we don't have r all by itself over there. What do we have over there in our list of formulas? What's the closest to r being all by itself? R squared. That's the closest to r being all by itself. We have sine theta. What's the closest to just sine theta we have? Y equals r sine theta. So both of those are missing an extra r. So quite often when we solve something like this and we're trying to go from polar to rectangular, quite often we're going to need to multiply everything by r. But if we choose to multiply by r, we must do it to both sides. Because what you do to one side of an equation, you must do to the other side. So we'd get r squared equals 4r sine theta. Now we have stuff that looks exactly like our formulas. What could I replace r squared with? X squared plus y squared. What about the right side? What can I replace
The r sine theta for what?
the r sine theta with y? Now again, we can't isolate y. We can't just say y equals blah. So usually on an equation like this, they'll end up with a constant on the right, all the variables on the left. So x squared plus y squared minus 4y equals 0. But that's not even necessarily a step we have to do. It depends on what you're using it for as to what form would be the most useful. So a lot of the times you have to multiply by r. Not every time, though. The try problem is a little easier as long as you recognize some stuff from the beginning. What should we recognize on this one? R squared's already there. R cosine theta's also already there. So this one's more like our rectangular. This one's more of a plug and chug. I don't really have to do anything to it at all except replace. If we replace, what should we get for our final?
X squared plus y squared plus 4x.
Just for x, not for x squared, equals cosine theta. So again, we did no calculus today, just some pre-calc review of polar coordinates. We'll start in on some of the calculus with polar coordinates tomorrow. And a couple of them are just graph it in your graphing calculator. I just want you to become more familiar with what are these going to look like when I do graph them. And it talks about finding the appropriate viewing window. I don't really care about that because the calculator can do that for you if you do
Do
Zoom
we just
Fit.
write it down, or do we just put like, yes, I did?
But I want you to actually draw the picture on your paper. You just don't have to be super...
Picture of your calculator.
Oh, good. I'm already ahead on that step.
Draw a picture of the graph shown on your calculator.
I think we should just go with Josh's idea, but yes.
I did that in Hager's once and she counted it. It was just like, show it, so I just put done. Graphed it.